I really was afraid I had COVID. I had every symptom in the world of it. Thank God I was negative. So, yes. Especially since it was my birthday week. That was not a fun way to spend a birthday. Well, thank you. I actually ended up having a very good birthday. A very, very good birthday. Let's see here. I'll put that up here, just go over that. You want to know how good my birthday was? It was that good. So, yeah. Thank you. Yeah, I was blown away, needless to say. So, yeah. All right, how did y'all feel about the test, the exam? Give me a show of thumbs, up, sideways, or down. I'm seeing up, I'm seeing down, I'm seeing sideways, I'm seeing across the board, but I see quite a few ups. That's good. Okay, and how about the quiz? Did you guys all get to take the quiz? Okay, well, guess what? Because I'm in such a good mood, because of the aforementioned picture I just showed you, I'm actually going to reopen it. Because it only opened halfway during the day on Friday. So I'm going to reopen it to be due tonight. How's that sound? If you haven't already done it, or whatnot, there you go. So, anywho, okay, so it takes me, because of the number of people I have, and because I do go through line by line by line, it usually takes me about 10 days or so to get an exam back. Right, because I don't just say yes or no, it's right or wrong, or all, half, or none, like some people do. I try to go through and give partial credit where I can, right? So it benefits you. Okay. So let's see what we got here. This is, of course, the updated one, and so hopefully you're able to see the 3.1, 3.2, and 3.3 videos before today. Were y'all able to see those? Anybody? Raise your hand if you saw the videos. Not many people saw them. Okay, remember, this class is flipped. It's making an assumption that you watch the videos, and it's all based upon this calendar. So again, I really recommend printing off this calendar, and if it says we're working on this, that means I'm going to go over it, but with the assumption that you've seen the video beforehand. So make sure you see it beforehand, otherwise you may be going, what? Because my goal is to kind of just quickly go through what I showed you on the video and then give you some additional practice and answer questions over it to let you go a little bit deeper and really understand it. Okay, so let me put that aside, and now let's look at it. All right, and this is actually pretty straightforward stuff, and certainly if you've had calculus before, there is nothing new here. And if you haven't, it's not bad. It is always the algebra behind calculus that makes calculus difficult anyway, and I know you guys are all well versed in algebra. But this was the 3.1, derivative. All right, what is a derivative? Well, it is your instantaneous rate of change, all right? It's called a derivative because it is derived, literally derived, from the parent function, whatever we start off with, all right? Which is why our nomenclature is the way it is. If your original function is f of x, then your derivative is f prime of x. It shows the relationship between the two. All right, we've certainly seen this before. Again, I'm just going to kind of glance through this because the assumption was that you've seen this already. This is, as you know, all right, the difference quotient. All right, this is also the difference quotient. If you take the difference quotient and you take the limit of that as h approaches 0, you have your derivative. You have your instantaneous rate of change, because recall that h represents the distance between the two x values. As that distance becomes nothing, the secant line becomes a tangent line, which is the instantaneous. Okay? And these are your different interpretations of the derivative. And again, you've seen a lot of this before. And again, all these notes are all on Canvas. All my printed off notes filled in, all this stuff is there. All right, what is this? Well, it is the slope of the graph at a particular input, slope of the tangent line, okay? The rate of change of f of x with respect to x at whatever this input is, all right? And that's what I pointed out here. This is where the applications come in, because the derivative represents how the function is changing at that precise moment. So lots of applications there, Okay? Now this is important. Okay, these are the conditions at which a derivative does not exist. All right, so it does not exist at a hole in the graph, at a jump, or an asymptote. Any point of discontinuity, there is no derivative. Okay? Because what is a derivative? Remember, it represents the slope of a tangent line. Well, if you have a hole there, there's no tangent line. I mean, yes, the derivative itself, the limit itself may exist, but not the derivative. Jump, asymptote, same thing. Okay, an oscillation, again, it's not approaching any one particular number. Okay, at a point at which a tangent is vertical. Well, why? Well, again, if it's the slope of the tangent line and you have a vertical tangent like right here, that means that slope is infinity, does not exist, right? All right, good. Now this one always throws people because the derivative does not exist at something called a cusp. Had anybody heard of that before? Oh, good. Oh, excellent. Okay. A cusp is basically a vertex, if you will, or a corner, a point. It's a sharp coming together of two lines, if you will. Okay. It's not a smooth curve. This would be a smooth curve, right? But if you come and you have a corner here, all right, the derivative does not exist. Why? Well, it's because the derivative represents the slope of a tangent line. What is a tangent line? You might raise your hand, tell me what a tangent line is? Yes, sir. Bingo, the line that touches only one point of the graph. How many tangents can you get at a corner? It's like, how many tangents can you get on the head of a pin here? An infinite number, right? So if that's the case, there's an infinite number of slopes. You have infinity there, does not exist. That's why. Does that make sense? Cool. All right, and this just shows determine the intervals over which the graph is positive. All right, the derivative is positive implies what? Implies the tangent slopes are positive. In other words, you're looking at the slopes of the where they're going up from left to right. All right, and that would be where the derivative is positive. Does that make sense? Okay. Now why are there, let's see here, where are we here? At x equals 7 here, okay, so from 5 to 7, all right, what do we have here? Well, we have our endpoints here. Why did I put parentheses around it? I didn't put a bracket around that. Yes, sir? Okay, good. So right there, that makes sense. You're right. That's a cusp right there. And what does 0 mean? Huh? And so I wouldn't put brackets around it because 0 is what? Go ahead, help out.
It's not positive or negative.
Right. It's the only number that does not have a sign. And I think that's what you were saying. Right. It's not positive nor is it negative. And so the takeaway here is whenever you're asked to give intervals of being a positive tangent or positive derivative, negative derivative, never put brackets. You will never put brackets, okay? Because at that endpoint, the derivative does not exist. At a 0 slope, it does not exist, okay? If it goes on to infinity, well, obviously you can't control infinity. You certainly would put parentheses there. So always, always, always parentheses, never, never brackets. Make sense? Any questions, guys? Anything? Okay, cool. Awesome. All right. Then we get into actually doing the work of it. And then we did this in 2 ways. Okay, using both limit definitions of the derivative. Here are the 2 limit definitions. They were from the first page of these notes I just rewrote. All right, this gives us an actual value at a equals 9. All right. So you have f of a plus h minus f of a over h. You're just replacing every single a with 9 and compute it that way. And again, this is just algebra. All right. And over here, f of x minus f of a over x minus a. Well, that certainly looks like a slope formula. All right. Let x approach a. Okay. The distance goes to 0 between them. And again, you're just plugging it in. If you are given the choice, this is a good takeaway here, guys. If you're given the choice of how to find a derivative when you have an actual input value, then usually number 2 is easier. generally speaking. And it's just, there's always exceptions to the rule, but that's just a general analysis there. Okay, usually this one if you're given the choice, but you may not be given the choice. You may be told use this particular definition and determine the derivative at a particular value. In any case, on both of these, you'll see the answer, of course, is the same here. All right, it's just two different ways to do it. You're plugging it in, all right, and then you're just using algebra here. All of this is just algebra. All of this is algebra here, right here when you're evaluating this all the way down. Just algebra, it's all that is. But I find that algebra always throws people, all right? You see why this, I took how many steps here? Let's see here, 1, 2, 3, 4, and I got my answer. And this here, 1, 2, and I got my answer. So clearly this was a little bit shorter. So that's why I tell you that earlier. Does anybody have any questions over these two problems that y'all saw? All good with it? Okay, good, good. Y'all usually really vocal on the question, so this must be good then. And I appreciate that. I appreciate y'all being vocal. My other classes are quiet all the way through. It's like, I don't know if they get it or not. All right, cool. And yes, we're going to be doing some practice here. I'm going to give you some problems to work out. Okay. Now this was specific. This was use the limit definition to compute f prime of a. And again, you could use either one. It doesn't tell you which one. And then find the equation of the tangent line. Well, we have an input. It didn't tell you we had an input, but we had this input right here, okay? Because we want to find the equation of this tangent line. It's x, of course, equals -4. Add x equals -4. Or in this case, you could call it a, whatever you want to call it. All right, and then we just plug it in. And once you get that, and you take the limit, okay, because we want it to equal -4 here, okay, because it's x minus a. As x approaches a in this case is -4. Then you come down here and simplify it, and you get, when you plug it in and take the limit, you get your slope is equal to 24. There's your slope. And now just use your basic y equal mx plus b. Let me zoom this out so you can see the whole thing, to actually answer the question. Okay, anybody have questions on this? Yes, ma'am.
Why do you use -4 as a when it's the x value? Like, why don't you use for x?
Well, they're saying at f of x minus f of a at x equals a. And a, in this case, is the numeric value that we're evaluating the derivative at. The numeric value that we're evaluating it at, okay? So f of x is our original function, minus f of a minus the function evaluated at whatever x value we're told, okay? And so it gives us this ordered pair. There's my x value. So in my original formula, I'm going to replace this a, which is the numeric value that I want to replace, with what I'm given. Does that make sense? That's why I use that. Okay, no, good question. Any other questions on this, guys? Are we all good? Okay, cool. Cool. All right. All right, that's a good, actually, let me just go, because I don't want to bore you to tears. I want to give you a problem to work out. How about that? Let's try one. We'll do a few. How about that? Make it more interesting. I'll get a couple here. I'm going to make them up, too. I don't know what I'm going to write down. I'm just going to write something down. Okay. So we're going to use limit, definition of derivative. I'm abbreviating for space, which we want lim of f of x plus h minus f of x all over h as h approaches 0. So I'm telling you to use this one, okay, to find f prime of x, your derivative, for f of x equals, oh, I don't know what it would equal. Give me a number. 4. 4x squared plus or minus? Oh, I heard both. Plus. Oh, you want it? Okay. Well, we'll start off with the, okay, don't want to deal with negatives this early in the morning, huh? All right, let's see here. Give me another number. 8 plus 8x. We'll leave it at that. Okay, so the formal limit definition for this. All right, and I'm going to let you guys take a few minutes to work it out, and then we'll talk through it. Now, if you've had calculus, I'm sure you know the power rule, which is your shortcut. If you were told to find the derivative using the limit definition, you get no credit for using the shortcut. However, that being said, and you will all know the shortcut here in a little bit, I would always use the power rule to check my answer to make sure I got it right. Okay? If it doesn't tell you you have to use the limit definition, then you can use whatever method you want. Anybody get an answer? What did you get for your answer?
8x plus 8.
Yes, who all got 8x plus 8? Using the limit definition, of course. Okay, good. Because if you know the power rule, you can look at it and see what it is. All right, cool. Yeah, let's go over it then. All right, so if you didn't get that, then 99 times out of 100, it is a simple arithmetic mistake, and that's where you have to be real careful with the limit definition. But the first thing you want to do, okay, and this is a good rule of thumb, first thing you want to do is you want to find what is f of x plus h. All right, so you want to take this, and then when you find that, you're going to subtract from it your original f of x, and you put it all over h. So your first step is to find out what is f of x plus h. Well, here's my advice to you. Take it with, a grain of salt if you wish. However, I'm going to tell you, having taught this for years, that the easiest way to not make those little mistakes is to do this one little thing that looks silly, but I'm telling you it makes a difference, and that is this. Before you go plugging in whatever is in parentheses, rewrite your original function, and where there is an x, you take it out and you put in parentheses. Now that may seem silly or a little extra work, but I am telling you it will make all the difference in the world, because otherwise you may not distribute right. If you don't have those parentheses, you may not FOIL it like you need to. You'd be surprised. And okay, now once you take out the x and you open up parentheses, then we're going to fill in the parentheses with this. You're just going to fill it in, x plus h, x plus h. Okay, and at this point it is simple basic algebra. Basic high school algebra. Simplify it. You do not need any parentheses here because we're going to have to simplify this further. All right, so that would equal what? What's the first thing I'm going to do here? Do I distribute the 4 first? No. What do I do first? Multiply it, FOIL it, distribute it, however you want to call it. Exactly. So I'm going to say 4, and there is a shortcut to this. Okay? Whenever you are squaring a binomial, the shortcut is this. You will always, first of all, always have 3 terms, never 2. You'll always have 3. So square of the first term plus square of the second term. I think that makes sense. But that third that is always there, you would get this way. You take your 2 terms here, you multiply them together, and then you double it. Okay? X times h is, of course, xh. Doubled, you have positive 2xh. And that's how you can avoid having to actually FOIL it out. Now, if you forget how to do that, or you're not sure, when in doubt, FOIL it out, okay? And then simplify it. And we're going to distribute this to both of these, 8x plus 8h. It's easy to forget the 8 on this last one, or whatever the coefficient is. Same thing here. Now we want to distribute this, so f of x plus h equals 4x squared plus 4h squared plus, it's easy to forget the last one, 8xh plus 8x plus 8h. We all good with that? Okay, good. All right. Now that you know what f of x plus h is, simplified, now simply plug them all into your definition. You're going to take that, and you're going to subtract from it your original function. So this is going to be lim, don't forget, you have to rewrite lim, as h approaches 0, of f of x plus h, which is all of this, 4x squared plus 4h squared plus 8xh plus 8x plus 8h, a lot of 8's there, okay, minus, make sure you use parentheses. If you just say minus and then your function, then you're not going to distribute that negative to where it needs to be, and you're going to make a mistake. The original function was 4x squared plus 8x, and it's all over h. So far, so good? Now, this looks awful, but the nice thing here is it shrinks down a lot. If you do this right, it's going to shrink down a lot, because this negative must be distributed to both of these terms. So you're going to have this as a minus 4x squared minus 8x. And there are 2 ways, 2 checks to know you've done this right. Your first one is this. Every single term in the original function should cancel. Every one should go away. All right? This is minus 4x squared. Negative 4x squared, here's a positive. Boom, he's gone. This is negative 8x. Here's a positive 8x. Boom, he's gone. They all cancel. Now, don't just assume you're going to cancel because I told you they're going to cancel. Make sure if you distribute the negative, it does cancel, right? I've seen that before, too. So this is lim of 4h squared plus 8xh plus 8h all over h as h approaches 0. See how that shrunk down so nicely? Okay, this was your first check. Here's your second check. If you did all the arithmetic and the algebra correctly, then every term in the top must have an h in it. If you end up with a term without an h, something went wrong. Go back and check your work. Some little something went wrong. And the reason is this h has to cancel, so we have to factor this out. Lim, h approach 0. I'm going to factor out an h from the top. That's going to give us 4h plus 8x plus 8 all over h. Now, do you see what I can do here? Change colors just to make it look nicer. Boom, it's gone. All right, so this is now going to give me lim 4h plus 8x plus 8 all over nothing. I mean, I can put 1 there if I want. I don't need to. Okay, notice I rewrote lim. Why? There's still an h. I have not actually done this operation. If this variable is still present somewhere, you haven't done it yet. Rewrite it. But now I'm going to do the operation, plug in an h here. This goes to 0, and what am I left with? 8x plus 8, which equals, tie it to the original, f prime of x. That's what you were asked for. If you're asked to find f prime of x, then you must state that. Otherwise, you haven't stated that you knew that was f prime of x. Does that make sense? Any questions on that, guys? Yes, sir. Sure. Mm-hmm. 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 Well, the first one is basically this one, okay? There's an A for the, well, that was X. It would be, it's pretty much the same. Let me go back to that page here. The second one, you can use either one. Yeah, as h approaches 0, a plus h at f prime of a. They're using, what they're doing here is they're simply using two separate variables to represent the same thing. A here, if you would say, let's say that f of a equals 4a squared minus 3a. Okay, it's just the name of the function. They're saying that the independent variable here is a. The independent variable we usually see is x. It could be f of t, f of r, f of whatever you want to call it. Does that make sense? Okay. So for this definition out of the textbook, they used an a here. Okay. Now they're using this here, and this is kind of confusing when you see the 2 here. Okay, because this, you still, okay. Let me back up a second here. For this definition here, and what they're not really telling you here, and that's, I probably need to go back and rewrite this out. You are given a numeric value here for these two. Yeah, you are saying, and they would say like, given a equals, I don't know, 2. Okay, then you can certainly plug that in. Does that make sense? They are interchangeable. They would give you the exact same result. Yes. No, sir, not if you're not told. Okay, if you're just said, using a limit definition, find the derivative, you could use either one. Yep, exactly. If I give you find at a numeric value, or if I give you a problem, you find the derivative using the limit definition and write an equation of a tangent line and a point, obviously I'm giving you an input, right? Whichever one, choose whichever one you want. However, if I'm not giving you an input, if I'm just saying find the derivative kind of like this, 9 times out of 10, I'm going to tell you to use this particular one. Okay? No, that's a good question. Thank you, because I'm sure I needed the clarification of everybody. Okay, any other questions on this before I give you another one here to try? Okie doke. All right, let's try another one then. How about, let's see here. How about you're going to do the same thing for lim of f of x plus h minus f of x all over h as h approaches 0, and let's do f of x equals, let's see here, 2 over x. Again, if you know that power rule, which you will all know here in a little bit, then it's pretty straightforward. You can look at it and see what the answer would be. But I'm telling you to use that, so you have to show the work. This one's a lot shorter. Actually, easier math. Well, I guess that's relative. Okay, anybody get an answer? Yes, ma'am.
I got 2 over x squared.
You're just missing a sign, that's it. Anybody else get something similar? Yes, ma'am. Yeah, negative 2 over x squared. Yeah, you just missed that sign there. Anybody else get negative 2 over x squared using the limit definition? Okay, cool. Let's go over how we do this. Yes, it's a process that is actually very straightforward. It's actually only just a few lines to do it, but it involves something that you may not like, and that is fractions. I know we don't like fractions, do we? We hate fractions. Fractions, you know, they're not bad. Really, they're not bad. All right, so let me just show this to you. I need to unfreeze it. I'm going to zoom it in. Well, the easy part here is, of course, figuring out what is f of x plus h. Well, I'm going to take this out, and really, without anything around it, I'm just going to put in, I'm going to put in x plus h. This is the one time I'm going to say it's not terribly risky to do that because there's no coefficient of the x, there's no power of the x. So f of x plus h is equal to 2 over, replace the x with x plus h. There's your f of x plus h. Right? And then your limit is lim, of course, of f of x plus h, which is 2 over x plus h. All right, minus f of x minus 2 over x, and it's all over h as h approaches 0. And that probably looks awful to you, doesn't it? Yeah, I kind of figured it would. So you know what I would recommend doing? This is what I would do. I would get it out of that compound fraction format. You got fractions within a fraction. This is what I would do because it will, your eyes will glaze over a little less. I'm not saying they're going to totally not glaze over, but a little less if you do this. Simply rewrite this. Lim h approaches 0 of what? This numerator here, 2 over x plus h minus 2 over x. And instead of dividing by h, the exact same thing, the equivalent, is to multiply by the reciprocal of h. And then I would tell you to focus only on this. Just focus on this. Leave that 1 over h alone. Just keep it out to the side until you simplify that. You've got to simplify those 2 fractions. You need to subtract them. How do you subtract fractions? You get a common denominator. Find your LCD, and then again, like I said about the h, leave it alone. Do not mess with that denominator. Don't give yourself more work than you need to. You do not need to do that. Okay? What is the LCD here? Who said that? Raise your hand. Good job. X times x plus h. It's easy to think that the LCD would simply be x plus h because there's an x in both. And you would be right if there wasn't a plus between those two. If that were an xh and an x, then yeah, that would be the LCD. But that's a binomial. X is a monomial. They are not like terms. All right? One does not go into the other evenly. So I'm going to show you. I've already got this worked out, so I'm just going to show this to you right here. Let me zoom it, and I'll walk through it. Okay, so there's your LCD. X plus h times x, or vice versa. Okay? So if you do top and bottom by that, and I'll also tell you this, when your LCD is simply the product of the 2 here, then your numerator is simply gotten by cross multiplying. X times 2 is 2x, you'll see here. All right? Negative 2 times x plus h. Negative 2x minus 2h. Distribute that negative. It's easy to forget that little negative there. It's the same as multiplying top and bottom here by your x and the top and bottom here by your x plus h. It's the exact same thing. Okay? That's my LCD. Leave it alone. Don't bother distributing it. You're giving yourself more work. It's not going to hurt you to, but there's no sense in doing it. Just leave it alone and just simplify the top. Now you see that the two non-h terms cancel out like we need them to. They go away. You're left with negative 2h all over x times x plus h. Just don't forget your little 1 over h here. That h and that 1 over h down here, that's what has to go away. And the only way it's going to go away is if every term in the top here has an h in it. And that way you can factor it out, or in this case, you can cancel it because this h is not attached with a sign. It's side by side. You can just knock them out. Does that make sense, guys? We good with that? Questions on it? Good. Well, at that point, then we just continued on down. Oh, yes. Mm-hmm. 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 Perfect. You bet. Yeah, it would work just fine. Because basically what you did is you canceled out the denominators. And as long as you do that to the top and the bottom, you're golden. Absolutely. Good question. Any other questions, guys? Make sure I can see everybody. Okay, cool. All right. Well, if that's the case, we're going to jump ahead now and look at the shortcut. So if you haven't had calculus, you're going to appreciate this. And I'm going to show you the shortcut by going back to a problem that we started off with here, the first one I had you guys do. Okay, so we started off with this guy right here. F of x equal 4x squared plus 8x. And you saw all this work that we had to do in order to get our answer using the limit definition of the derivative. So now let's say, okay, I'm going to rewrite this problem. F of x equal 4x squared plus 8x. All right. By the way, what is the power of that x right here? 1. I don't need a 1 there. I'm just going to put it there just for demonstration purposes. So here's your power rule, your shortcut, f prime of x. If you were to take this first power of 2 and multiply it by the 4, what would you get? 8. Write down your x. Now subtract 1 from 2, and what do you get? 1. Good. Plus, now repeat the process here. Take that power, multiply it by the 8. What do you get? 8. X to the, subtract 1 from this power. What do you get? 0. What is anything to the 0 power? Yeah, unless it is 0 itself, you're absolutely right. Anything to the 0 power is 1. That gives us 8x plus 8. Boom. You're done. After you see this, the other one looks like torture, right? But again, if it tells you, and I would probably only do that with one problem on the next exam where I have you do the limit definition. But I will tell you, it will be on the next exam and it will be on the final. Even when we do departmental finals, it's always present, always, because it is the true formal definition of a derivative. Having said that, like I said, it's easy to check your work using this. You'll know you did it right, okay, if you do this. Yes, sir. You have a question? I beg your pardon? Sure, absolutely we could do that. Let's do the power rule of the 2 over x. You bet, and that will work beautifully. All right, f of x equals 2 over x. Good. All right, so first thing you need to know is to use your power rule, you need to get any variable out of a denominator, get it out of fraction form. Well, 2 over x, isn't that the exact same as 2 times x to the what power? Negative 1. Now use your power rule. F prime of x would equal, take the power, multiply it by the current coefficient. What do you get? Negative 2. Write down your x. Take 1 away from the power, what do you get? Negative 2, exactly. All right, that's negative 1 minus 1 is negative 2. Boom, your calculus is done. Now simplify it. Negative 2 stays in the top. That power is only attached to the x, all over x squared. Make sense? Cool. That is your power rule. Okay, and in the notes, this is what it goes over. Okay, and this is where I talked about derivatives. All right, the power rule. These are your notations. We've already seen f prime of x. You probably could figure out y prime. dy dx is frequently used. It's read derivative of y with respect to x, your independent variable. All right, or if you are evaluating a derivative or you're asked to find this, say dy dx, and it has a long vertical bar, and then you have at x equals 4, that means find the derivative and evaluate it at x equals 4. Okay? And then this would be your formal power rule. You see, you take the power, multiply it by the current coefficient. In this case, it's just 1. And then take 1 away from your power. Okay? And then it gives you some pretty basic examples here. Okay? And let's see here. We had some examples here as well that I went over. All right. In the notes here. And since, you know, the assumption is you've already seen it, I'm not going to just have you work them out. Okay, but the part I had on top here is if the variable is in the denominator, move it to the numerator. Okay, the other rule of thumb here is if you have a radical, you must rewrite it as a rational exponent. Remember, power rule is all based on the power, which is the exponent. So if you have something in a radical form, like this guy right here, this is 5 over 3 times the 5th root of x squared. Rewrite this. That's the same as 5 over 3 times x to the 2/5 power. Remember, the root always goes in the denominator here. And then you take this, not the 3 stays there, and then just move that guy up. And then you use your basic power rule. And that's true with all of these. Okay, does that make sense, guys? Is it pretty straightforward? Okay, good, excellent. Okay. Now on this bottom one down here, and I made a note here that hopefully you saw. All right, this was evaluate this derivative, okay, and using your power rule here. And you would definitely want to power, you wouldn't want to do that using I wouldn't do that to you. I would not do that to you, okay? Let me make that clear. I would not make you do this with a formal definition. That would be mean. I'm not a mean person. I'm just saying. Okay, especially when I'm in a good mood. All right, note, do not plug in the number before taking the derivative. If you're using that power rule, then you evaluate it and then plug it in. Why? What would you get? What would happen if you plugged in the number first and then did the derivative?
It would all be constant, so just like
Bingo. It would all be constant, and so it would be 0. 0 would be your answer. All right? 0 would be your answer. Why? Because, let me give you a demo here as well. Why is any derivative of any constant equal to 0? Let's say your function is y equal 3. Okay? Y prime equals 0. Why? Here's the why. I can rewrite y equal 3 as y equal 3 x to the what power? Not 1. 0, exactly. Because that's the same as 3 times 1, which of course is 3, right? Use your power rule. Y prime, take the power, multiply it by your coefficient, and what do you get? 0. You would have 0x to the negative 1, 0 over x, which of course is 0. And that's why. Basically, whatever you start off with, it's always going to cycle down. All right, so if you have like an x squared, your derivative is going to be x. If you have an x to the 4th, your derivative will be x to the 3rd. It's always going to go down one number. Okay. Were there any questions on this page? On any of those problems? Again, I went over in pretty good detail on the notes, video. Okay, cool. Q. Okey-doke. Graphs, that usually throws people. Okay, identifying the graph of a derivative. The graph of f of x is shown here. Here's your original function. Which graph would show the derivative? All right, so this always throws people. This is probably a good one to go over. So let's look at this here. So here's your original f of x function. You notice that at this point, okay, it is below the x-axis, okay? At this point, it is above the x-axis here. Now your derivative is also what? All right, well, this is going to be negative slopes, okay? These are positive slopes. This is a 0 slope, negative slopes, okay? 0 slope. All right, well, if it's a 0 slope, well, where x is 0, that's the x-axis. okay? If this is negative, well, where is it negative? Well, that's below the x-axis, right? So if it's a negative slope, you need one that is below the x-axis. Here's below the x-axis. Right here is 0. All right, well, where is it 0? Well, that's where it crosses the x-axis, right? And then this is positive from here to the 4. So that's going to be above the x-axis from here to 4. Okay, and this is just because this is just rates of change. It does not mean it's a decreasing graph. Remember, this is a derivative function. And again, I went over that in a lot of detail in the video. Did anybody have any questions or further explanation on that? All good with that? Oh, that's good. That's real good. Okay, cool. Okay, and this was your rule of thumb. So if you didn't write that down, this is a good thing to know, because when you're evaluating graphs, just from experience, I always get lots of questions on that. All right, where you have a negative slope, negative tangent slope, all right, that means that it is below the x-axis on the derivative graph. Regardless of the curve, it doesn't matter. It just has to be below the x-axis on the derivative graph. If it's positive, okay, then that means it has to be above the x-axis on the derivative graph, and if your slope is 0, then that is your intercept. All right, so if you can keep that in mind, if you can memorize that, then you're good. You're not going to go wrong. Make sense? Cool? All right, awesome. All right, now, let's see, differentiability. Oh, there's a word for you. There's the word of the day, differentiability. I don't think I even said that right. Differentiability. Say that 3 times fast. That's a tongue twister. Implies continuity. Okay, if it's differentiable, then it is continuous. But is the opposite true? Nope, not necessarily. Okay, continuity does not guarantee differentiability. Why? Because of the cusp situation. All right, clearly a absolute value graph is continuous, looking at it, but it's not differentiable everywhere because there's a cusp there. Okay? Good. Okay, good. Any questions on E? The only function that is its own derivative. Are y'all good with E? Yes. For E, okay, E is a unique number. E is an irrational named number named after Leonard Euler, the famous mathematician who discovered its properties. It's like pi, a famous named, very applicable irrational number. And there's a proof behind this, why it is its own derivative. There's a whole proof behind that. But for our purposes now, just assume that the derivative of e raised to the x power is itself. Now, if you have a coefficient, coefficients don't go away. I mean, they could simplify down, and that's true with the power rule. All right, but if there's no coefficient, or if there's nothing else here, then you just leave it alone. Okay, so the derivative of e to the x is e to the x. Now, when we get into chain rule, we're going to get into a little bit more on that, but that is the way this is. Now, notice I have that the g of x equals e squared and g prime is 0. Why is that true? Because what? Exactly. There's no variable. I mean, it looks like e is a variable, right? E is a number. That would be like saying g of x equal 4 to the 2 power. What's the derivative? 0. Little trick question there. All righty. That, let's see, and then after that, we're going to get into, and then we'll get into the product and quotient rule. And if you haven't already seen the video, please do watch that and the other ones coming up. And we'll do a lot more practice next time. I certainly don't want to keep you all late. So have a great rest of your day, guys.